Hello and welcome to another video with Lowell's Doo and how to use LEGO Mindstorms. In this video I'll be discussing how to use the wait block. I'm going to start off by placing a start block, because it makes sense that way, and by just running through the basics off a wait block. Alright, so you can see that when you put the wait block on the screen, it's a rather small block, and you have the hourglass symbol, which is generally used for wait, and the amount of time that you want the robot to wait. So what the wait will do is it'll stop the robot from doing anything, or it can let the robot do what it was doing if the robot was told to continue doing that until stop. I'll explain that little confusing part later on. So you can enter an amount of seconds here, and the robot will wait that amount of time. Alright, but I don't know why I did that. Alright, but today I'm mainly going to be talking to you about sensors using the wait block. Alright, so you can notice that there's a time symbol. If you click on this, you get a rather big drop down filled with sensors. Well, for the most part. The only things that aren't sensors, sorry about that, are time, messaging, and brick buttons. Messaging and brick buttons are sensors in a way, but time isn't a sensor whatsoever. So I'm going to start off with how to use the touch sensor because that's fairly simple. Probably the most simplest sensor that there is to use. Alright, so let me just say what I want the robot to do before I actually start programming it. I want the robot to move forward until the touch sensor is pressed, and then I want the robot to stop. Okay, so it's fairly simple once you know how to do it, but before you do, it's rather complicated. So, to start off, first you need to make sure that the port is correct. So, it's defaultly set to port 1. If you are connected to the EV3 brick, it'll automatically do that part for you. But if you're programming at home without one, like me, then you would want to make sure that that's where the port would be when you have the robot. The next thing you have to do is tell the robot to start moving. That can be done by grabbing the move block, placing it, taking the wait block and putting it after the move block. Telling the robot to move forward a certain amount of rotations is not what you want to do, because it will complete doing this and move on to the wait block. What you want the robot to do is turn both motors on. When both motors are on, it'll be on until you tell the robot to stop. But where does the wait block come in all of this? The wait block does what it does what the name says it does. It waits. So if I were to put this wait block in between here, what would happen is the robot's motors would turn on, and this block would then be finished, and the process is now complete. The motors will not stop spinning, but this block is done, and it'll move on to the next block, which is the wait block. The wait block will wait until this value is met. This value over here. So if you drop down on this, you can see that it has released, pressed, and bumped. We want it so that the robot is bumped against something. But bumped means that it pushes and then backs up. That isn't what's going to happen. It's just going to get pushed. So, pressed. Once the robot's touch sensor is pressed, it moves on and the robot will stop. This is a fairly simple process, but it's a very important part when it comes to programming with the EV3 robots. I'll run through this program again. So, both the robot's motors turn on at a power of 50 going straight. Not really important right now. Once this block is finished, which is just to turn the motors on. It isn't to continue for a certain amount, it's just turn the motors on, that's it, go to the next block. The wait block. The wait block will wait until the touch sensor is pressed, and we decided that when we clicked 1, which is pressed. And once it is pressed, it'll move on from the wait block to the next block, which is to turn off the motors. Hopefully you understood that, and I just realized that I forgot to show you something. It's where you get this from. So you go to touch sensor, compare, and state. 1 minute, I'm just going to check the amount of time that I have left. Okay, I still got a good amount of time. So I'll run through what changes. So right now we were working with compare and state, change, and state. Change in state is just when it changes, it'll output true or false, where you can plug into true or false things, but I'll get into that later. Funny thing, I just realized that that did not exist. And if you would excuse me for 1 minute, sorry about the email, that was just an email. Yeah. Alright, so I learned that the weight block does not have anything for change. That's for ultrasonic sensors and other sensors which have data values. Forget I said that. And I'll cut away again. I am really sorry about all the email notifications. I just closed Outlook altogether. Alright, so as I was saying before, I was rudely interrupted by my email. The weight block will just wait until it is complete. So, this is fairly simple. This is a measured value. Remember how over here you had like numbers 0, 1, and 2? Well, if it's 0, the way LEGO Mindstorms works, let me just run through that. The way LEGO Mindstorms works is it has basically number values for almost everything. It has, sorry, not number values, but it has like a value. For example, this is true or false. You can see the check mark or the break mark. X, sorry. So, this has the numbers value 0, 1, and 2. So if the value is 0, which means that the touch sensor is released, this will output 0. And I'll get into how to make that actually do something later on. So I'll run through another sensor. I'll run through the ultrasonic sensor because this one's kind of neat. So if you're in Canada, you'll be using distance centimeters. If you're in the US, distance inches. And no matter where you are, you can use this. You can use inches if you want, but in Canada or the US, they like usually stick to their measurement scale. 1 minute, check time. Alright, I'm back. Sorry about all those cutaways. Okay, so this one's rather, it's a teensy-weensy bit complicated, but you will learn it. That's guaranteed. Alright, so this is pretty much the same thing. It waits until this value is met. Now, how do you change this value? Most of you will just go, oh, look, amount of centimeters, and then type in a number. But this actually can do different things depending on what this is. If you are past, I believe, grade 1, you should know what these symbols mean. If you don't know what the symbols mean, don't worry about it. Alright, so equal to, not equal to, greater than or equal to, less than or equal to. Remember how I said before about how they all have the number values? You have number values too here. 0, 1, 2, 3, 4, 5. Alright, so which of these do you choose? Equal to is not a really preferable choice because sometimes there's a lag between, but this will get you exactly where you want to be. But there's a foolproof way to getting this to work. Less than or equal to, less than, and you have these 4 options, which are probably the most useful ones. So, I'll get into greater than. Greater than means that if the ultrasonic sensor value is greater than 100, it'll continue. The value is met. Greater than or equal to means if the value is equal to 100 or greater than 100, the value is met and it will continue. And let's quickly do this. 4. Less than. If the value is less than 100 centimeters, it will continue. This one is probably what you want to use if you want the robot to stop at a wall. So that when the value becomes 99 centimeters, it'll stop. Less than or equal to is probably the best one because it will stop at 100. If it misses 100, it'll stop at 99. That's why this is useful. So that's basically it for the how to use sensors. I'll be back with my next video soon. Until then, bye.